Welcome to Arduino Sensors. Today we're going to take a look at sound sensors. Now I have here a big and a small. Now these don't have a part number. It was impossible. I looked online. I couldn't find any kind of data sheets for these. There's a number on here, the HW-484, and that's just the board. That is not the actual sensor. These boards are used for lots of these sensors, lots of them. It's basically just an OP amp kind of set up like a comparator is the best way I can figure out how it works. But I played with them and tested them, and surprisingly the one with the smaller speaker, microphone, seems to be a little more sensitive than the one with the big. It might just be my particular sensors. I don't know. They both work the same. There wasn't a whole lot of difference, and what we're going to do here is take a look at using it. Now there's 4 pins, and they're both the same. There is the analog pin here. Then the next pin is the ground. Then there's the positive. Then there's the digital. Now we're going to take a look using the digital because that's the main reason this board is set up this way. If you were just going to use analog, you might as well just take a microphone and plug it directly into one of the analog pins and analog read it that way. But you can still use the analog on this. But like I said, we're going to take a look at the digital. And what we're going to do is we're going to make a clapper or a loud noise sensor that will turn a switch off and on, or a relay or whatever you want. But for demonstrations, I just put a LED in here on pin 13. But you could, like I said, use this to turn on and off a relay, or pretty much anything that you could connect to the Arduino to control from a loud noise being made. Even maybe you want to set it up for a camera to take a picture if there's a loud noise. But all right, let's get into it. I have the board already wired up, so I'm just going to put the big one in first. Get it set. The digital pin goes that way. We're going to power it up. It'll take it just a moment. All right, now when I clap, oh, there we go. The first time I found, when you first plug it in, sometimes it takes a little louder of a noise. Also, I found it gets a little more sensitive after you let it be powered on for a couple of minutes. I'm assuming just everything warms up and works better. Now, let's try it now. Snapping ain't quite loud enough, but you can adjust the sensitivity on these. Now, when you're holding it like this with the pins facing you, there's this little potentiometer here, and this is a multi-turn. It's not just one turn, it's a multi. So what you do to be less sensitive, you turn it clockwise. To be more sensitive, you turn it counterclockwise. And there's a little LED that comes on down here, right here, when the thing is activated. So what you'll do is you'll turn it down if you want it real sensitive until that LED turns on. And then you'll back it off until that LED just turns off, and that's when it's going to be its most sensitive. Then if you want it less sensitive, so the noise has to be louder and louder, just continue to turn it turn it clockwise. Now I'm going to unplug that one and plug this one in. The same sketch works for both of these. All right, got to repower it on. There we go, and the sensitivity on this, I've got to adjust it. There we go. Now you see this one, like I said, it seems to be more sensitive. It'll pick up a snap, where this one wouldn't. As the TV commercial used to go, clap on, clap off. But we're only using one clap to turn it off and on. There are some other sketches out there online. I'll let you look that up, that it takes account. You have to do a double clap for it to work. So, all right, let's go over to the computer and we'll take a quick look at the sketch for this. Okay, I've got the Arduino IDE opened up here. And as you can see, the sketch we're using here isn't very complicated. So what we're doing first is I'm just defining, we're using the LED is what's being turned on and off. And I put it on pin 13 because the resistor is already built in, and there's an LED on the board as well. Whatever you want to control, just define the pin you want it there and then give it a name. Then we got our sensor, and I just called it sound, and I have mine, the digital output of the sound sensor, connected to pin 3, digital pin 3 on the Arduino. And then I have two booleans here. And what we're doing, the trigger here is what's going to be, when it's in the loop here, we're going to be reading the sensor, and we're going to store whether it's true or false, on or off. And that's what we're using that boolean for. And then the state, we're just doing true and false, and that's keeping track of if the LED is on, then it knows to turn it off, or if the LED is off, it'll know to turn it on. And you can see right here in the if statements how I have that done. We'll get to that more in a second here. Then in the pin mode, we're just setting LED as an output, and pin mode for this, the sound sensor is an input, of course. So then what we're doing here, like I said, we're reading, digital reading the sound sensor. And so we're doing a trig equals digital read sound. And then we've got an if and an else if statement. So if the trigger equals false, which how this works on those boards, when there is a digital output, it means nothing has been detected. Now once a loud sound is made, or a sound that it's set up to detect, so it's sensitive enough to detect, the digital pin state goes low. So of course that would be false. So when the trigger pin equals false, and the state, which means if it's on or off, and when you first plug it in, the LED will be off, so that means it's false. So what it does is the digital writes the LED high, it changes the state to true, and then delays 500. And that's just a debounce, so when you clap, it doesn't turn off and on, or on and off real quick. So you're going to want to have a little bit of delay there. Just don't put a delay in the loop itself, because then you might miss the clap. And I don't recommend trying, you can use interrupts as well, but when you use interrupts, you can't use delays in there, so you kind of lose your debounce option. So running in a void loop is the best way to go. Now make sure in your second statement here it has to be an else if. If it's just an if statement, once it turns the LED on, well then it'll continue through the sketch and it'll see, oh, well, no, there's another if statement, so it'll turn it off right away. If you have an else if, if the if statement here is true, then it will skip any of the else ifs, and then of course at the bottom here, it'll come back up to the top. And in the else if the trigger equals false, which means the digital pin goes low, and the state equals true, which means the LED is on, then it's digitally writing the LED low, turning it off, and switching the state back to false. And then again, a delay of 500. These sensors are extremely easy to use, lots of applications. You can make a clapper to turn a light on and off using a relay. You could have a sound alarm, something with a loud sound like a window breaking or something, set off. Oh, excuse me there, set off an alarm. Or you could have a loud sound, make a camera, take a picture, whatever you want to connect. We'll leave that up to you. So, all right, I hope you found this information useful. Please remember to like, share, and subscribe. And with that, I'll just say I hope you have a great day. And remember, have fun building.